Welcome to the session of Object-Oriented Programming through Java. And in today's session, we are going to discuss what are the object-oriented programming concepts and why these concepts are important when you want to learn Java. And you know that Java is a purely object-oriented programming language. Means Java uses principles of object-oriented programming. So what principles are called object-oriented programming principles that we are going to discuss in this class. And there are certain features to say that any programming language is a object-oriented programming language. It should follow certain principles. So what are those principles? So these object-oriented programming language principles were developed in early 1980s, and these concepts, if any language make use of these object-oriented principles, it is suitable to develop a variety kind of applications, like real-time applications you can develop, and you can develop internet-based applications. You can develop distributed applications. You can develop network-based applications, like that. Variety kind of applications can be developed if the programming language supports object-oriented principles. And when a language is supporting object-oriented principles, so the program is done using a concept called classes and objects. What are the class? What is the class? And what is the object that we are going to learn in today's class? So, object-oriented programming principles means it is having certain concepts. Object-oriented programming language principles follow certain concepts. What are those concepts? So in an object-oriented programming language, you should have a object and a class. A class should be there. And the data abstraction principle must be used. Data encapsulation principle should be used. And the message passing will be there. And the inheritance will be used. Inheritance is supported by the object-oriented programming language. And it also supports polymorphism principle. So these are called object-oriented programming language principles. Means any programming language which supports object, classes, data abstraction, data encapsulation, message passing, inheritance, polymorphism. So these concepts are called object-oriented programming language concepts. So any language which follows these principles, that language is called object-oriented programming language. Now we are going to discuss about one by one about these concepts. First, what is an object? So object means any real world thing or any real world entity is considered as an object. Every object in the real world entity is having certain properties, and these properties will describe about that object, and the properties are also called attributes. Properties are also called attributes. So every object, real world object, is having certain properties, certain attributes. So those attributes are talking about the object, are describing about the object. And I give an example. What is an object? So you can take in the real world a thing like a fan. Fan can be considered as an object. You can take a chair. Chair is an object. You can take a bed. Bed is an object. You can take a refrigerator. So refrigerator can be considered as an object. You can take an employee working in an organization. So he can be considered as an object. A student studying in a university or in a college can be considered as an object. What properties are associated with these objects? Suppose if you are taking an example of fan as an object, what properties are there? A fan is normally there in a circular shape. So it's a shape, circular shape. So it is one property. And a fan is having wings. Every fan is having either 2 wings or 3 wings or 4 wings. Every fan is having a motor to rotate that fan. So motor, DC motor inside that fan or AC motor inside that fan is another property. So like this, every real world object is associated with a property. Suppose you take a student studying in a college. So he is associated with certain properties. When you call a person as a student, so if any person takes admission in a college, then that person will be called as a student. So once he becomes a student, he will get certain properties. An admission number is associated with the student, and he is also associated with the year of study, and he is also associated with the course, which course he is doing, BTech course or MTech course or diploma course. So course and year of that course is another property. And subjects, what subject? Subject 1, subject 2, subject 3, subject 4. The student has to study all these subjects, and the marks associated with those subjects is another property. And total marks obtained by the student and percentage, academic percentage is another property. So these are the properties. Student hall ticket number means roll number, student name, and course, which course he is studying, and then year of that course, and then subjects associated with that course, and marks scored by student in that course, and then total marks and the percentage of marks. So all these are the properties belonging to the student. So if you take any object in the real world, it is associated with certain properties, and these properties are called attributes, and these attributes are represented in the program in the form of variables. Attributes are represented in the form of variables in the program. And then object is also associated with certain behavior. Behavior means the actions performed by the object. Suppose if you are taking the fan, what action is performed by the fan? Fan can rotate. So rotate is the action. When the fan is rotating, it can spread the air. It can circulate the air. That is the task of the fan. That is the function performed by the fan. And similarly, you have taken student. So what actions are performed by the student? A student can attend the classes regularly. A student can listen to the classes patiently, and a student can perform write operation. A student can perform read operation. A student can attend examinations, and a student can score marks in the examinations. Okay, these are the actions, certain actions performed by the student. So reading action, writing action, attending action, listening action, playing action, sleeping action. So these are the tasks performed by the student. When the student is performing these tasks, certain results will be produced. Means when an object perform operations, certain results are produced. And how these actions are represented in the program. The actions of an object are represented in the program using functions. So in object-oriented programming, functions are called methods. So actions of an object are represented using methods in the program. So this is the object. So concept of object. An object can be anything in the real world, and an object is associated with certain properties and behavior. Properties are represented using variables, and behavior means actions done by the object are represented using methods. And the next concept of object-oriented programming is called class. What is class? A class is nothing but it is a plan for an object. It is a template for an object. It is a blueprint for an object. A class means it is a plan for an object. Without a class, there is no object. Means without a plan, you cannot create the object. Plan should be there. Then only you can create an object from that plan. Means class is a plan for an object. If you want to have object, first you have to plan for that object. Then only from that plan, means from that class, you can create an object. Okay, so if the class is existing, then only object is created. If there is no class, there is no object. Okay, so which one is first? Whether object is first or class is first, means class is first. If you are having a class, from the class you can create an object. But what is the difference between an object and a class? An object is a real world entity. Physically it is existing. But class is not a real world entity. It is just a plan. That's it. A class is a plan. It is not existing in reality. Okay. So once a plan is made, from that class you can create any number of objects. N number of objects you can create once a class is planned. Once a class is designed, you can create any number of objects from that particular class. So I will give one example for what is class and what is object to better understand a class and object. Suppose assume that you want to construct a house. To construct a house, directly we don't start the construction of the house. We will plan on the paper how our house should look like. So a plan is prepared on the paper. Okay, where we need to have bedroom, where we need to have kitchen, where we need to have drawing room, where we need to have hall, where we need to have children bedroom, where we need to have parking area, where we need to have guest room. All that is planned properly on the paper. Once that plan is finalized, then only we will start the constructing house. So constructing house means creating real world entity. Constructing real world entity. So this house is called object. Object means real world entity which is existing in the world, which is physically there in the world. So house is physically there in the world. Okay, so that is object. And whatever plan you have made on the paper, so that plan is called class. So from this plan, once a plan is made on the paper properly, so using that plan you can construct any number of houses which is following this plan. Okay, so that when you are constructing different houses, house number 1, 2, 3, 4, using this plan, so all those houses will look similar. So this is means once a plan is finalized, once a plan is created properly, so using that plan, using that class, you can create any number of objects, means houses. And here the difference between class and object is the class is a plan which doesn't require any resources in the computer system, but object is a real world entity that requires space. Means if you need to have a object, means a real world entity means house that requires space. To build your house you need space, physical space. Similarly, an object in the computer requires space in the memory. It occupies memory space, whereas class doesn't require any memory. It doesn't occupies any resources. It doesn't read any computer resources. But object requires space in the memory. For its execution, it requires CPU time, and for its execution, it requires different resources like input-output devices, or file resource, or database resource. So many things are required for the class, for the object. So object requires resources, whereas class doesn't require any resources. So this is the difference between a class and an object. Then coming to the third concept of object-oriented programming principle. So that is data abstraction. So what do you mean by data abstraction? So before going to this data abstraction, we will see how a class is represented in the program. So a class is very similar to the structure in C program. So if you are familiar with C language, probably you have used structure. A structure is defined using the keyword struct followed by structure name. Similarly, in object-oriented programming like Java, a class is defined using the keyword class followed by class name. And inside the class, we are declaring properties of the object. And these properties are nothing but variables. Properties are nothing but variables. We can declare the variables. And along with the variables, we are also having behavior of the object. So behavior is nothing but actions or functions performed by the object. They are represented using method like reading method, write method, attend method, listen method. Just now we discussed about student object. A student object is associated with student name, student hall ticket number, and branch of study, year of study, subjects, and then total marks, percentages. So these are the attributes. They are represented using variables, suitable variables, and then actions performed by the student. So that is read action. Student can read, student can write, student can attend the classes, student can play games, student can sleep. So all these are the actions performed by the student. So this is how a class is represented in the program. A class is represented using the keyword class followed by the class name, and inside the opening and closing braces we are writing the properties of that class and the methods belonging to that class. And if you want to represent a class in the diagrammatic format, here it is shown in a rectangular box. The rectangular box is divided into three sub boxes. In the first sub box we have written name of the class, that is student class. And in the second sub box we have represented properties of the student, that is student is associated with the name, roll number, and marks in the subjects. It's subject 1, subject 2, subject 3, total marks, and if you need percentage. So all that you can define there. And then actions performed by the student. Some actions are like read action, you can represent a write action, attend action, all that you can represent input, the compute, display in the student details, all that. These are the actions done by the object. So this is how a class structure is represented. Now coming to the data abstraction. So this is the third concept of object-oriented principles. What is data abstraction? Data abstraction. Abstraction means the name itself it is representing. Abstracting. Abstracting means giving only partial details and hiding all important details. Means data abstraction is a concept where we will hide most important details of an object and only we provide a little information about that object which is required to the user. Means we are not going to tell complete details about an object to the user because it is not required. Whatever is required about an object to the user, only that information we will provide to the user. And the remaining important information about that object we will hide from the user. So this is called data abstraction. So data abstraction is most important principle because here we are not providing all details to the user. Most of the important details are hidden from the user. So therefore your data is safe, your data is secured, your data is protected from the unauthorized access because user doesn't know what is there inside. Whatever information you are providing an object, user feels that only this information is available. Okay, so therefore your data is secured. Okay, so that is called data abstraction. In order to understand this data abstraction very clearly, I will give one example. Suppose you take an example of a car. Car has engine. A car contains engine, and a car contains steering. A car contains brake pedal, and a car contains accelerator pedal. A car contains clutch pedal, isn't it? Here, car contains engine. That engine is made up of using different technologies, but that engine is not shown to the user. It is covered. It is hidden by using the cover, body cover. Okay, so that users they do not see the engine, and they are not aware of what technology is being used and where that engine is manufactured and what parts are there inside that engine, how that engine is working, how the fuel is burning inside the engine. All these details are not provided to the user because user doesn't require who is purchasing the car. So they need not be provided with these details because these details are not required to the user. What is required to the user? The user, when they wanted to purchase a car, he will look into whether I am comfortable with this car or not, whether driving with this car is simple or not, whether using this car I can go very fast at a high speed on the highway or not. So, and whether it is providing all latest features or not. Okay. So user is bothering about only that, but the user never bothers about how the fuel is burning, what technology is used, where, which in which factory that engine is manufactured, and how that engine is fitted here into the car. All that details are not required. They are hidden using a bonnet. The engine is not at all shown to the user, isn't it? So engine uses a technology. Lot of mechanism is involved. All that is not revealed to the user because that is not required. Similarly, you are having a steering. The steering is shown to the user. But what technology is used for the steering so that when the user turns the steering left, so that the car is taking turn left. So how car is turning left? When the user rotates the steering towards left, tires, front tires are moving left towards the left side and the car is taking left turn. And when the user moves the steering towards right, the wheels are moving, front wheels of the car are moving towards right side direction and the car is taking right turn. See here, the user here bothers about when I rotating the steering, whether wheels are moving in proper direction or not. He wants only that. But when a steering is moved, how the wheels are moving and what technology is used there, how the steering is connected with the wheels, what mechanism and what parts are used there. So all these details are not shown to the user. Similarly, when the user is driving a car, as if you wanted to go at high speed, just he is changing the gear and giving the accelerator, pressing the accelerator pedal. And when the accelerator pedal is pressed, the car moves very fast. How car is moving when the pedal is pressed? What mechanism is working inside? That what technology is used? The user doesn't given all that details. What user want when I am pressing the accelerator pedal, whether car is moving very fast or not. When I am applying the brake, whether car is stopping or not. So user want only this. But what technology is used to develop that brake so that when user presses the brake, automatically car is stopped. What technology is working inside that? How that brake is connected to the wheel? How the brake pads are being applied on the wheels? All these details are hidden. They are not shown to the user. Who will bother about all that? Only the manufacturers and the designers of the car, mechanical engineers. They bother about the design of engine, design of wheeling mechanism, design of steering mechanism. So all this technology and designs they will hide from the user. And the users are provided information about You are having steering in the car, you are having gear rod in the car, you are having clutch pedal, and you are having brake pedal, you are having accelerator pedal. You can use them to drive your car safely. Only that information is given to the user. So remaining all technological details, internal details, implementation details, technological development details will be hidden from the end user. That is called data abstraction. Data abstraction means hiding most important details of the object and showing only whatever is required to the user. So that is called data abstraction. So how this data abstraction is implemented? Data abstraction is implemented using the class definition. So previously we have defined class. Okay, using a keyword class followed by class name. Inside the opening and closing curly braces, we have defined variables. So those variables are highly secured, and that data is not shown. Those variables are not shown to all functions in the program. Only the functions which are defined inside that class, only those functions can access that data. Other functions which are not belonging to the class cannot access that data. But in procedure-oriented languages, it was not like that. Once you have data in the program, the data can be accessed by any function. When a non-related function can also access data in procedure-oriented programming language. But here, in object-oriented programming languages, it cannot be accessed. So this is called data abstraction. And what is data encapsulation? So data encapsulation is nothing but combining properties and object and its associated actions. Properties means attributes and actions means methods. So combining data and methods together as a single package, as a single unit is called encapsulation. Encapsulation means packing. What we are packing here? The data and its associated methods. We are packing them into one unit. So that unit we are calling it as class. So data encapsulation is achieved using class definition. A class contains variables and its associated methods inside the class definition. So this class definition is called data encapsulation. So data encapsulation is achieved, means packing of data and its associated methods is achieved using class definition. So you can see here a class definition for student is given. Student is associated with his name. Student is associated with roll number. And the student is associated with the subject 1, subject 2, subject 3 and subject 4, 5 and so on and the total marks. You can have any number of variables there. And then associated methods like input method, compute method, display method. You can have other methods also, read method, listen method, sleep method, play method, all methods you can have. Any number of methods you can define inside the class, there is no restriction. And similarly, any number of variables you can declare inside the class definition. So class will combine the variables and its associated methods. So like this, combining variables and its associated methods inside one unit called class. So this concept is called data encapsulation. So binding of variables and methods into a single unit is called data encapsulation. So data encapsulation is achieved using class definition. Okay, so here what you have to remember is inside the class you can have any number of variables and any number of methods. There is no restriction. And whatever methods you are defining inside the class, only those methods can have access to the data defined inside the class. So non-member methods means the methods which are not declared inside the class cannot access class data. So means the data is secured from the access by non-member method functions. So that is the thing you have to remember here. That is data encapsulation. And another concept that is called message passing. Normally, classes cannot communicate. Suppose inside one program, if you are having two classes, one class cannot communicate with another class directly. So all that communication will be done through the objects of that class. The objects created from the class can communicate. The objects belonging to one class can communicate with the objects belonging to another class by sending and receiving the messages. But that message passing should be supported by the underlying operating system architecture. Different operating systems, they support different ways of communication among objects. If the underlying operating system is supporting that communication, then only you can develop programs to have objects to communicate by sending and receiving the messages. If the operating system is not supporting, then it is very difficult to develop the program. So these are the some of the object-oriented programming principles. So in this session, we have discussed about what is object, what is class, and what is data abstraction, and what is data encapsulation, and finally what is message passing. And in the coming sessions, we are going to discuss in detail about what is inheritance and what is polymorphism. These are other two most important principles of object-oriented programming languages, inheritance and polymorphism. So that we are going to discuss in the next session. So thank you.